Welcome to my presentation. In this presentation, we shall see the definition of limits and also see the properties of limits. So the definition of a limit of a function is as follows. If the value of the function f of x can be made as close as we like to L by taking values of x sufficiently close to a but not equal to a, then we can write the limit of a function f of x as x approaches a is equal to L, like this. I'm going to put a box around this, and this is how we can define that. We can read this expression as follows. The limit of the function f of x as x approaches a is equal to L. That is the definition of limit of a function. There are some properties associated with limits. So let us look at some of these properties. The first property is, before I explain the properties, I would like to say let b and c be any real numbers and let n be any positive integer. So then all of these properties make sense. So limit of a constant value b as x approaches c is going to be equal to the constant value b as is. The second property is the limit of a function. If the function is x, as x approaches c, the value of the function is going to take over the value of c, like that. The third property is the limit of a function of a exponential function x to the power of n as x approaches c is equal to c raised to the power of n, like that. The fourth property is the limit of a radical function nth root of x as x approaches c is going to be equal to nth root of c, like that. Okay, so we have seen the definition of a limit of a function, and we've also seen properties of limits. In my next presentation, we shall see operations with limits.